morning, everyone. Welcome to D3 Technologies webinar, Become a Multilingual Programmer. My name is Nick Narzinski, and I am a solution specialist on the CAM side at D3 here. And today we're going to take a look at using AnyCAD in conjunction with Inventor 2017 and Inventor HSM for programming our parts. So this is actually a re-recording. The live run that we went through on this, the recording did not come out very well, so I apologize for those of you who had technical difficulties watching it, but hopefully this comes to a lot clearer and we're able to share some good valuable information for you guys. So, got a quick PowerPoint here, and then we'll get right into the presentation in the software. So what is AnyCAD? What can it do for us? Basically, we were able to reference part files and then use those referenced parts for programming so that we can spit out our G-code. Where this is really handy is non-native files. So here you can see an image of DWG, SolidWorks parts, CATIA. It doesn't have it on here, but STL, step files. It can not translate, but rather reference all those types of files into Inventor so that we're not having to remove the link between the two. So where you update it in one system, it also updates with inside Inventor. So we'll see how that looks here in just a little bit. Our key learning objectives, we're going to look at how to reference and or convert non-native Inventor files into Inventor. Then we're going to also see how we can import your legacy AutoCAD data. So anything that you have in 2D drawings from the past, you can actually reference that geometry as well. So we got 3 examples in store for today. We're going to take a look at a SolidWorks file, a step file, and then last one do is an AutoCAD DWG into Inventor. So without further ado, let's jump right into it. So here we have Inventor, and first one we're going to look at is a SolidWorks file. So let's jump into SolidWorks real quick just so you can see what it looks like. I'm going to open up this CAM part. You guys have probably seen a demo of this already in the past. This was created within SolidWorks. Here you can see how the feature tree builds up the part. So we have an extrusion, a couple cutouts. We did a couple holes, and then patterned that around and mirrored it. And last thing was adding a chamfer on the top edge and throwing a hole in the bottom as well. So here we have our part. It's already saved. I'm just going to go into Inventor, go to Open. And in the past, when you were able to open up SolidWorks files, but what we're able to do now is, let's go to the right folder here. So Documents, I got SolidWorks. There's that same folder, 2D. And so right now it's looking for Inventor files. So we're just going to change that to all, or we could be more specific and say just SolidWorks. There it is right there. And here you can see that CAM part. So we're going to say open, and in the past you've always been able to do this, but at this point it would just convert it into either a solid or a surface. Now we have the option to reference that model. And you can see there we have a little symbol of chain links showing that they're chained together. So we just say okay, it opens up quickly, and here we get a little symbol in our browser showing that that part is now being referenced, and it's titled cam.sldprt. In fact, if we expand that, you can actually see it brought in not only the finished part file that we can see, but there's also another part file in the background of another solid body. We can turn the visibility of that on. So there you can see that there was a stock built into this part as well. So it works with multi-body models. It also works with assembly files. So any of those that you're trying to import, we can pull them straight into Inventor. You can even constrain them and use them within Inventor high-level upper assemblies and have sub-assemblies from other CAD products as well. So it's really an industry changer as far as bringing together all those worlds. But specifically today we're looking at how we can use this in conjunction with Inventor HSM. So we're going to do or switch right over to the CAM tab, and here you can see all of our operations and the features from the ribbon of the CAM environment. So I'm going to turn that solid back off. We're not going to use that for this quick example. Today is not going to be a how-to program a part. It's more of how to use it in conjunction with AnyCAD, so I'll go through the programming process rather quickly. But if you guys have questions or we have other, you can contact me. I'll put my email address up later. But you can also reference some of our other webinars that we have on YouTube as well. So first thing we're going to do is a setup. And initially it found the outer limits of that entire part file. So that includes the non-visible stock size that we had shown in there, so the multi-body model. So what we're going to do is clear the pre-selected model and just choose this file. You can see now it shrinks down to the part file that we're working with. So that's kind of an important step. We always want to be working with, we always want to tell it what we're programming to and what we're cutting from is going to be on the stock tab. So for now, I'm just going to reorient my coordinate system. So select the stem, the surface I want it perpendicular to, and then I can move by selecting that ball there, or triad as I call it in the software, and then move it to a certain point. So this is going to be our G54, our work offset. I'm then going to move to the stock tab. We'll say that this is a fixed box size, and I'm just going to use the defaults here. So we got 4 by 1.5 by 1. And then post-process tab, you can give it a name and comment, but we're just going to change this to 1. That's going to be our G54 work offset, and we'll say OK. So we now have our first setup, and now I'm just going to start adding some toolpaths. So I'm not going to program this part from start to finish. I'm just going to throw a couple on there so we can see how this works. So I do a facing operation. We got our same 5 tabs for all operations in the browser here. First thing we always do is pick a tool. Let's go to by type. Let's find a face mill from the library. So this is just a search folder here. Here's my folders and libraries down below. So all face mills, 1 3/4, and geometry is automatically looking within the stock down to the top of the part. I do want to add a few multiple passes in here, so I'm going to go to the passes tab. Just check the box for multiple depths, and we'll say 0.07, 70 thousandths, and say OK. So there's our facing toolpath. Now I'm going to follow that up and do just a quick 3D adaptive on the entire part. So let's say adaptive, come back into our library. Let's find a 1/4 inch end mill. Hit OK, go to the geometry tab. So 3D operations are always looking at the solid model as a whole and the solid stock. So we don't necessarily have to tell it. We can limit the boundary of where we want to cut, but I'm going to rough out the entire part. So I'm going to keep it to machining boundary none. Our rest machining, I do want to change that. Instead of looking at the whole setup, I want to look at also that facing operation we already completed. So I'm going to say from previous operations. That way it knows what's already been removed, and we're not going to recut any of that material on the top of the part. And then check the box for from setup stock also. So let's go to the passes tab, our optimal load there. There's our step down value. I am going to change the stock to leave to 5 thousandths, and everything else should be good. So let's say OK there. There's roughing out the outside. We're going to helix down, do the profile for the inside. So quick and easy way to rough out that entire part. That's a couple tool paths. You know, you also have to chamfer and drill and tap the holes or deburr. So we're just going to go with those two. We'll do a quick simulation, make sure there's no collisions or anything. Which there is not. They would show up automatically already. You can go to the info tab and see here we have detected collisions none, so everything looks good there. I do want to change this to operation so we can see different colors for different operations. I'll speed this up just a little bit. All right, so there's the face. Here's the adaptive clearing roughing strategy, and that is leaving behind by default that 5 thousandths of material. So that's where you see a little bit of extra stock there being left on the walls. So one more pocket to rough out here. We could have moved that heights tab down just a little bit so we're not helixing so far above the part. But besides that, it looks pretty good. So I'm going to close that. Now, let's say we had this whole part programmed where you would be ready to load it and machine it. You go in post-process and select your post that you're using, and it open up inside the Inventor HSM editor, and then you can load that G-code. Now, let's say the customer or maybe somebody else within your company who's not using Inventor, maybe using SolidWorks, decides that they need to make some changes to the model, but we've already got it programmed. Well, with this AnyCAD, having that reference as opposed to converting the solid, we're able to just update the model in its native format. So I'm going to select and let's just extend this part to 3.5. And hit the check there. And then also want to come in and edit the number of holes here. So we got a circle pattern. Let's edit that feature. We'll say that there's only 4 holes instead of 5. And say OK. So there we see the part's been extended by 1 inch, and our pocket geometry has changed in addition to the number of holes. So some pretty significant changes to the model. We're just going to save that, jump back into Inventor. Initially it looks the same, but what has changed, and you may not have noticed it, but this part, or this little button up here for local update, is now highlighted. Before it was grayed out, kind of like this forward button is right now. Since this has a local update, we're just going to select that. You see the part grew and our number of holes changed, so we are referencing that SolidWorks part file, and we also have some red X's over here inside the CAM browser, telling us that those toolpaths are no longer attached to the geometry. So if you highlight them, you can see that they still look like the old part looked like. So the way around that is you just select the setup and click generate. It's going to regenerate those toolpaths to that new geometry. So here we can see the face and the adaptive have all updated. We can double check and verify with our simulation again. And that all looks pretty good. So then we just have to repost out to the machine and we're ready to rock and roll. So there's no going through and reopening that part and copying and pasting operations over or reprogramming the part from scratch. It's all integrated within the Inventor solution. So that is how AnyCAD works with other CAD formats. Let's say you're sent a step type of format where it's just a dumb solid, as I like to call it. It doesn't have any features that build it up from any CAD system. It's just been exported as a solid. So I've got one out here. Let's open up. Let's go to D3 demos, 2D versus 3D. And I no longer want to look at SolidWorks files. Let's look at step files. So here I have a 2D versus 3D .stp file. So we're going to open that. And in the past, it would just open it up and convert it again to an Inventor file. Now we are able to reference that step file. So let's hit OK. And you can see that reference symbol over there, and there is the part file. So this is new in 2017, having the ability to reference or use AnyCAD for these step files, and I think it's awesome, especially for programming, because a lot of customers like to send those types of files over. So we can then go to the CAM tab and run through that same process. So we're going to do a setup. Everything looked good there. Let's just add our offset. Then we can throw a facing operation on there. Like type, flat mill. So I could go out and find those. Let's say we're running on the same machine as that previous part that we did. If you go up to open documents, you can actually pull out part files from other files that you have open as well. So I could go down and browse to that library or do a search in the search folders through here, or I can just highlight that part file, grab that 1 3/4 inch end mill or face mill, and pull it in here. So we'll do the same thing as far as depths goes. I think we did 70 thousandths if I remember right, and say okay. There may not be enough stock, so it probably looks like it only did 1 pass there. So there's our facing operation, and just so you can see what the stock looks like, we got just a little bit of stock above it on the outside, and then you can see what it looks like from the top view down as well. So we got our face. Now let's do a quick roughing strategy on the outside of the part. I will use 2D Adaptive for that. Go into my library. I'm going to pull a part out of this file up here. So we got a 3/8 inch flat mill. Move to the Geometry tab. I want to look within my stock to my pocket selection, which is going to be this outside edge. So you can see there we have a closed loop picked automatically by selecting that edge, and the blue shaded area is showing me the area that is going to be removed. Heights tab, you can then change your heights, maybe like your bottom. You might want to go to model bottom and then come down just a little bit so you can machine past the bottom edge of the part. Oop, I said okay there. Let's see what that looks like. I do want to go ahead and change my step over just a little bit. Let's go optimal load 1125, and we'll do stock to leave to 5 thousandths. That looks good. The ramp type shouldn't matter because we're working on the outside of the part, so it should be smart enough or intelligent enough to lead in from the outside, which it did. Awesome. So there's our roughing on the outside of the part. Now let's just throw one on the inside real quick. We'll use that same tool, this time doing 3D adaptive on these two internal voids. So let's go to Geometry tab, and right now it's looking at the entire part file, kind of like the last example. I'm going to limit that to a selection. So let's look within these two pockets. And then let's do from previous again, so it recognizes our facing that's already been done. On the passes tab, let's do the same load as previously. 0 for cutting minimum radius. This optimal load takes into account your tool engagement angle, so anytime it comes into an internal corner, it's going to account for that by taking a shallower step over to keep that consistent load on the cutter at all times. And let's do 0.005. And a fine step down of 0.375. Change my ramp in angle just a little bit, and let's go with 100 thou on the minimum ramp diameter. That should be able to ramp inside there and fit between those pegs. So here it's calculating. And there we have it, working in between all those. So we're helixing down, cleaning out the bulk of that material. Awesome. So we'll go ahead and run through a quick simulation, see how this looks. Looks like there are no detected collisions. Let's play that out. There's a face, or rough on the outside. You might need a little more stock on the bottom of the part to hold this down, depending on how you're holding your part, but this isn't a how to machine video per se, it's how to use AnyCAD, so we're going to forgive that for today. And you'll see here it's starting at the deepest value, and then it's going to step its way back upwards. So we're going to clean off the top of those pegs a little bit. It looks like the tool is too large to fit in between the peg and the wall of these pockets. So we might follow this up with a smaller tool using Rust Machine to come in and clean the rest of that up. And a quick, easy way to do that, you could just right-click and do Create Derive 3D Milling Adaptive, or I could just go to Duplicate, edit the second one, come in and change our tool to, there's a 1/4 inch end mill. Go to Geometry tab. It's looking at from previous still, so that's all good. Same selection, same heights. Let's change our optimal load to 100 thou. And I believe everything else looks good. Oh, actually, let's turn off Helix since we already got down to the. Well, actually, let's keep that on. Let's see what happens here. Okay, it looks like it was smart enough to recognize that that material's already been removed. So instead of helixing down to the bottom of the pocket again and just cut air, it is plunging down and then engaging the stock from the side. A few more seconds on the calculation here. These take just a little bit longer to do on these rest machine operations because it does have to run through the calculation of the previous operations. So there we have it. That's a good, we'll just jump ahead to that new operation. Looks like a good tool path. We're coming in and just cleaning up that extra material that was left behind from the 3/8" end mill. Awesome. So we'll speed this up just a little bit. So then you can post your code, load it into your machine, and start cutting. Now, let's say we got it all ready to go. We're about to cut this part. Customer emails us or calls us and says, "Oh, stop what you're doing. We actually need to make a change to this part. We need to make it a little bit smaller." So the customer says, "I got a new file for you." He emails us a new step file. In the past, these step files, you'd probably have to open it up and either copy these toolpaths and reassociate everything, and go through a lot of work to do that. But with the AnyCAD, we're able to just open up and reference the new step file. So the way to do that is we just go to our browser, and let's go to Inventor HSM, 2D versus 3D. Here's the one we're working on. We're going to change it to this one here. So the way to do that is we're just going to change the names here. So we'll make this one old, and we'll make this one the new one. So the way it works is it just has to have the same file name. So once you do that, those two have swapped. I close it out, and did I do the right name? Let's check this out. 2D versus 3D.stp. That looks right. Let me double check my spelling here. I'm expecting that button to be highlighted again. So let's go Inventor HSM demos. 2D versus 3D. Step file, that looks right. Nope, it doesn't look like it took it. Okay. Let me try making sure that I save this first. That's probably part of the problem. Part 4 works for me. Old. New. There we go. There's the highlighted button up there. So as soon as I click this, you'll notice the model is going to update. There, it shrunk down. So we shorten the part by 2 inches. And we go back to the cam tab. We have those red X's again. We just regenerate those tool paths. Let's just select that pocket there. The rest of them look like they were attached. So then you just run through, let it finish calculating. You can see the facing updated. And there's our roughing on the inside as well. So once those finish calculating, you go through and do your simulation again, post out the code, and then you can run that part again. So saving us a lot of time having to reopen, reconvert, reprogram that entire part. It's all done just through AnyCAD and hitting the update button. So all you gotta do is replace that file name with the same file name in its location, and it will update within Inventor. So the last example I want to run through is using your legacy AutoCAD data. This is something I wish I had a long time ago for a couple companies that I went through that were at the same time, or that when I was working there, we went from AutoCAD to Inventor, and having that old data and being able to reuse it can save you quite a bit of time. So in this case, we have a 2D drawing of a duck call barrel, and you can see here it was created within AutoCAD. We have some different layers being used on here. And the title of this is Barrel Duct Call. So we're just going to go over to Inventor, start a new part file. And in the past, you could, jump from program to program and do copy and paste, but then it's just a copy and paste file. You have single objects, and there's no linkage between the two different files. So this DWG, what we're going to do with AnyCAD is import that into here. So on the 3D Model tab, you see Import, or on the Manage tab, we also have Import there. So either one works. You go to Import, find that file, click Open. It's asking for a plane to put this on. I'm going to select that XY plane, and then it's looking for a base point in order to place that. And here we see that I'm placing it into a component that hasn't been saved yet. I haven't saved my part. I just started it. And then here we're saying we're inserting a associated DWG, which is what I want. So there we have it with inside of Inventor. So, and you can see over here it's calling out that DWG. So what we can do with this, you can't quite extrude it yet. It's still looking for a sketch. But all you have to do is go to a new sketch. We'll select that same plane. And then go to Project Geometry dropdown and project DWG Geometry. So you can select individual lines and pull those in. Hold Shift to deselect. Well, maybe not. Control. Nope. You can't delete them though. Okay, there we go. What I want to do is just window select those. So you can also do connected geometry, which would find linked lines within inside of that drawing, or you can also do blocks. This part was not drawn as a block, so it's not going to select anything with that. I am going to just window select the profile I want to rotate. So I window select that, click the X there, and I still need to close these gaps in my profile. So I'm just going to come up and grab a quick line and close those gaps. There we go. Say OK. And the last thing I would do is put in a single center line, so that way it knows what to revolve around. So I'm just going to start that from the base point and come up here somewhere. Click Finish, and then I'm going to go over here and revolve that. So there we see it revolve as a solid. I say OK. We now have a reference part straight out of AutoCAD into Inventor. Excuse me. So we can then go in and do the CAM process, do a job setup. Difference is this time we'd be turning this part. So I'd select the axis that it's going to be on. We're on the tool, our stock front. Let's do our offset. And that looks okay for demonstration purposes, so I'll say OK. And I could run through and program this part with my turning operations. For those of you who were in my last webinar, or for those of you who haven't seen it, you may want to check it out. Templates are an awesome tool inside Inventor. You can do create from template. I'm just going to come down and grab my turning template, which has a face, profile, and groove built into it. Just do create, and then regenerate. So there you can see the facing on the front of the part. I've got a profile doing the bulk of the removal on the outside, and then a grooving operation to come in to that area my profile tool wouldn't fit. Looks like I would need one more grooving tool to come in and cut this lanyard groove out. But other than that, that profile worked really well in this part. I've used it on many other parts before as well. So check out that webinar on using templates to speed up your programming process. Real good for drilling, tapping, those kinds of things as well. So then I can run through and do a simulation. And you can see a part comparison here as well. between what we programmed and what we have left to remove, so then you can go in and clean that up. So that's using that legacy AutoCAD data. If you ever have any needs to go in and change anything, you can, draw within the sketch of our part inside of here. So we can draw more geometry on here or put holes into it if we need to, any of that. Or let's say that you wanted to change the original source, we can actually come over here. Ooh, that's not what I didn't want to move. Undo. There we go. I just wanted to stretch this profile, maybe make it an inch longer or so. Save it here, go back to Inventor, and again we have that update button and a little lightning bolt over here telling us something has changed. We hit the update button and the model updates with it. Go back to the CAM tab, regenerate those tool paths, and all of those update with it as well. So hopefully that gives you guys a good understanding of that workflow between Inventor and non-native Inventor files in conjunction with Inventor HSM and programming. I really believe it's a game changer, and it's going to save you guys a lot of time on programming your parts. Or for some of you larger companies who may have multiple CAD systems, it's a great addition to your current tools. Having that ability to go in and just update any file that's been changed within the HSM. So if you guys have any questions, let me pull up my contact info again. Where's that? There we go. So there's my contact info. If you guys have any questions, feel free to call or email me. And hope this was beneficial to you guys. And sorry again for the live presentation, which we had some technical difficulties. And I will talk to you soon. Take care.